So we talked about missing values, and I insisted that we should not use the ultimate target for imputation of missing values. Okay? So the ultimate target should always be kept out of these stories. And this is a topic related to data leakage. When filling missing values using other variables, we should avoid any data leakage. Data leakage in general is the issue of training a model using any information that would not be available for a new case. So if you come back here and you assume that there is a new case, let me have a new color. This is a new case. And this new case has a missing value for the income. Okay. And the age is 22. The degree is undergraduate. It is working for private sector. And the industry is, let's say, hospitality. And because this is a new case, we don't know anything about its ultimate target, whether this person has a private insurance or not. Then we cannot use it. If we train the model to impute the missing values, that model won't work here. So we should always keep the ultimate target variable out of this story. Okay, so using a predictive modeling algorithm to impute missing values you should be aware of problem of the data leakage when you are using an algorithm to fill the missing values. Okay, and how to be sure that this data leakage doesn't happen here? Well, by excluding the ultimate target variable. Okay, so let's come back to our slide. Data leakage, we explained it, we defined it. In the missing value context, it is using the ultimate target variable of a predictive problem in treating the missing values of the prediction. If you do so, you are leaking the target variable into the predictors. So if you use the target variable, then you cannot fill the missing values of any new case. Also, you are cheating somehow. You are telling that, okay, in order to fill this value, let's have a look very quickly at the target variable. And actually, this is a cheating. We shouldn't look at the target variable when we impute the missing values. Example, the goal is transaction fraud prediction. The target is whether a transaction is fraudulent, a flag target. We have missing values in the variable device of the client. We use fraudulent alongside other variables to fill the device variable. So this is another example similar to the one that we have above. And this is a case of data leakage because we are using the ultimate target of the problem to impute the missing values. So data leakage in general inflates the predictive performance on the training set and breaks down the model on testing set. We cannot fill the missing values there, or the performance would be too low. So there are many problems regarding the data leakage. It's important for sake of simplicity and brevity to remember that in the context of missing values imputation, we should not use the ultimate target variable or the problem's target variable to impute the values. And I gave you some examples earlier, so I do not dwell on this topic anymore. What about the unacceptable values, the last thing about data quality? Well, the unacceptable data values is a conceptual thing. For instance, if you have negative values for the age, it is unacceptable. Okay, so it is a problem in the data quality. You have to remove those negative values. You have to figure out why these are negatives. Or in a data set regarding to airplanes, flights, let's say, arrival time should be after the departure time, right? But you have to check it. Otherwise, you don't know whether it is actually the case. It might be the case for some of the flights that in our data set arrival time is actually before the departure time. There is an error here. There's a problem of data quality. Negative or decimal values for variables like number of children, saying that 2.5 children, or child, better to say, or I don't know, children. And that's a problem. I mean, we have to consider it. A client with birth date of 1885. This is a problem. Probably it's 1985, not 1885, and just this error seeped into our data. A client whose age is not equal to the difference between today's time or today's date and date of birth. Okay, so if you calculate this, this should give back the age. But for this specific client, maybe this is not the case. So unacceptable values, there is no way to, like a technique to find these unacceptable values. You have to go through the data and think about variables. Think about what and how something might go wrong. So in the last slide, let's once again review things. So we talked about variable types. We talked about granularity, that if, for instance, we have a date 28/0.02/2022, we can break it down into components. This is a component, this is a component, this is a component. About the scales and the types, about the transformations and reclassifications that can improve the quality of data, about extremes and outliers, missing values, and unacceptable values. But what about the number 6? So the number 6 is again something conceptual, and it is about thinking. So maybe I should put it in a data set part, but here in the variable part also I can point it to. So it is about when you have a data set, you can think about every variable, that, okay, how this data set actually has been recorded and what might go wrong during the recording. Okay, so let's assume that you have sent some students to collect data using face-to-face interviews, and in that case data is very prone to error, because the interview is a long process, and you are prone to do error. So how to improve it then? Well, giving them or asking them to record the interview and using the automated speech to text apps to get the transcript of the interview. So it is about, again, thinking about every variable. And that was the story of this week about data quality. But this is one part of data quality. We will talk about anomalies, and then we will talk about duplicates, and data validity. So altogether would be the second part of data quality story. But I spare you from the rest of the story, and I will wrap up, I will end the lecture here.